Hello, everybody, and welcome to today's vOLTHA TST meeting. Thanks for joining. As usual, the call is recorded. It's public and will be shared on YouTube, so please be mindful of whatever you share and comment during this call. So today, we have a few items on the agenda. The first and foremost is related to logging, both an EFK logging showcase with the OpenVOLTHA agent integration and a log correlation with Girish and Divya from Infosys. And if we have some time, we can go to the investigation of the secrets from gRPC. There might be a Helm chart discussion, even though I think we're not going to get to these points given the extent of the great work that Divya and Girish are doing. So without further ado, let me give the floor to Divya and Girish. So please, guys, take the presentation rights and go ahead.
Okay, thank you, Andrea. Let me share my screen.
Yes.
So you can see my screen, right?
Yes, absolutely.
Okay. Yeah, Girish, you can start.
Yeah, hi everybody. So I think the way we have kind of defined this, okay, Divya, you want to probably go to the first slide, right? Okay, so the way we have planned is basically we are going to just talk about two areas which we have worked upon, right, in the last couple of months. And then Divya would take up one of the area and talk about it and demonstrate, and then I will follow it up. Okay, so just to give you a high level view before we, I think, go into that. Today's, I think, presentation, we are going to talk about what are the kind of different new features we are adding into the vOLTHA ecosystem and the last couple of releases. So in 2.3 release, we actually started off with a dynamic log level configuration, which allowed us to configure the logging, right, on the runtime. Then in 2.4, it was followed by the EFK setup, where we actually implemented a centralized log analysis kind of a support. In 2.5, it has been, I think what we are planning to introduce a log correlation and a distributed destination mechanism, which should allow us to do a troubleshoot analysis, right, of any issues happening in the system, and also do a kind of runtime analysis, right, how much execution time each of the part of the system is taking. So the centralized log analysis, Divya will talk about, and it will be followed by a demonstration, and thereafter I will talk about what a solution approach which we have taken in for log correlation and distributed destination, and followed by demonstration. So Divya, over to you to, I think, probably talk about the centralized log analysis, and then I will take over later.
Yeah, thank you, Girish. Hi everyone, myself Divya. So I'm going to talk about the centralized log analysis for a vOLTHA ecosystem. So the solution approach which we have implemented for centralizing the logging for the vOLTHA ecosystem through the EFK. The EFK is basically the Elasticsearch, Kibana, and Fluentd setup, which enables the operator to view logs from all the vOLTHA components in a single stream. And we have introduced a new flag code with EFK in the kind vOLTHA script, which allows you to set up a EFK with the kind vOLTHA deployment. So this deployment, EFK deployment is basically depends on the type of deployment you have chosen, whether it is a minimal or a full setup, full type of setup, and flag which you have set, that is schedule on control nodes. So this table shows you the number of pods deployed for Fluentd, Kibana, and Elasticsearch with the type of a deployment you have chosen, whether it is a minimal or a full, and if you have set this flag called schedule on control nodes. So we are doing a port forwarding for Elasticsearch pod and Kibana pod. So you can access these pods from outside the Kubernetes cluster. The port forwarded for Elasticsearch is 9200 and for Kibana it is 5601. So if you want to access a web interface of a Kibana, you can access with this URL. So by default, we are not enabling any security features and physical persistence feature for a EFK setup. But operator can enable authentication, authorization, security features by configuring in the YAML file by enabling the XPath plugin and role-based access in the Elasticsearch. Below are the links which you can use it for enabling the security feature with the EFK setup. So we have also done that we are pushing all the logs from the white box VOLT device to the EFK. So the solution approach which we have chosen for pushing the logs from the white box VOLT is we are installing a TD agent. TD agent is basically a Fluentd variant which we are directly installing on a VOLT device, and which actually transmit all the logs related to the processes which are running on the VOLT device to the Elasticsearch pod, which is running in the vOLTHA cluster. So for a HCore VOLT, we have used the Debian related package of TD agent. TD agent comes with the different packages for like a Debian, RPN, and all other variants. So we have used a Debian package with the Xenial variant. We have created a custom TD agent configuration file to handle the formatting of log files using the write input plugin. For OpenVOLT process logs, device management daemon logs, system logs, and we have added a Elasticsearch output plugin in this TD agent custom configuration file. And this configuration file, you can find it in a OpenVOLT agent repo. So there are some additional steps the operator has to do when he starts a TD agent. When he wants to collect the logs from the white box VOLT device, he has to set the Elasticsearch host and port in the TD agent configuration file. And we are and he's supposed to restart the syslog. So this diagram shows about how the EFK looks like. In a kind vOLTHA setup, we have a vOLTHA pods and EFK pods where we are EFK is pulling all the logs from a vOLTHA pods. And in the white box VOLT, we are running a TD agent service which pulls all the logs from OpenVOLT process, device management daemon process, and syslogs, and push it to the Elasticsearch pod, which is running in the kind vOLTHA setup over the TCP protocol. So we'll move on to the demonstration. So before that, I want to show. So I have already set up AFK and tracing with the kind vOLTHA using this flag. And you can see some additional steps are happening when we have enabled AFK and tracing. So you can see this one. There is one for some additional steps happen for the Agar for a tracing, and some additional steps for EFK. So this setup I have enabled with the authentication authorization feature. So I'll just show you the values.yaml file. So I have enabled authentication with the basic authentication and encryption feature for Elasticsearch. And for the same username and password, I have used for Kibana and used certificates for encryption and for the Fluentd. So I have already installed the TD agent on a vOLTHA device. We'll just see the configuration of vOLTHA TD agent. So this is a custom configuration which we have created for our requirement. This configuration file we have introduced with the input plugins and output plugin. This is the input plugin for processing the OpenVOLT agent logs. And I'm formatting the logs which are coming in with the regex, creating some fields such as the label, instance ID, caller, and a message. The logs which are coming and the label which is coming with these logs are coming in a single characters. So to harmonize with other logs, just I am expanding those single characters into the proper word, like I is for info and W is for one and E for error. And this is for a device management input plugin. This configuration is for a syslog where I'm doing port forwarding for the input plugin. And this is an Elasticsearch plugin. You have to configure host and port here for the log. And this is an encrypt certificate because I have enabled the encryption. So if you are not using any encryption and all, these fields are not required. Authentication, username and password, all those things. So we'll just start the service. Okay. We'll move to, we'll access the Kibana dashboard. So we can see some logs. Kibana.
So just to add, I think this is actually a Edgecore OLT, ASFX vOLT 16, on which it is running TD agent.
Yeah, okay. Thank you, Girish. So as I told, I have enabled the authentication, basic authentication with the EFK. So it is giving me this prompt. Elastic. Provide the username password. So once you log in, you can see nothing is available because it is a fresh setup. So we'll just add an index. Okay. Now we'll go and see some blocks coming in for the components.
So while I think Divya was started the presentation, in the background I have been actually accessing the same machine. I have actually created a device and enabled the device. We used actually BBSIM, not the actual device, but yeah, so it could have generated a lot of logs somewhere.
Yeah, you can see in the last 15 minutes, it has generated around 101988 number of logs. So these logs are from all the components which are running in the vOLTHA cluster, and as well as the processes which are running on the white box vOLTHA devices. You can see the logs for all the components. So just we'll check it for vOLTHA components. So vOLTHA components, all the vOLTHA components have the one key called instance ID. So we'll just check it for instance ID. So it will just give me the logs related to the vOLTHA components. So it went down. So for vOLTHA components, there are 54,000 plus logs in last 15 minutes.
Okay,
So
actually Fluentd actually collects log from all the containers, okay, in the Kubernetes cluster. So it includes your Kubernetes, the cluster internal parts, like which are in the kube system namespace, all the default ones. It also collects it from other, right, etcd and every all the logs, right, whatever the other containers are running. So with this instance ID, we only have filtered out other logs, and only the ones which are getting generated by vOLTHA application components, they are coming in now, like RW core, OF agent, and OpenVOLTHA adapter.
yeah, so mostly I am able to see the logs which are coming for RW core, because
And
okay.
which filter should I use if I want to see the core logs only?
Uh, uh, sorry.
If I want to see the vCore logs only, is there any specific filter for that?
Yeah, you can go here and select for the
I
pod
think you can
name.
just use the pod name, no?
Yeah, pod name, you can use it.
Or you can also use the instance ID. That's also a possibility. You can same use the instance ID.
So when you select the keyword, right, it will come up with the value options also. Here you can see all the options and pod names basically. So you can select those pod names, select it, just to refresh. So you can see the logs related to only the RW core pods.
Okay, thanks. So this will give all the Kubernetes logs as well for WO core, because I'm looking at the output. It looks like it's is it only the vCore logs, or is there some other logs in it?
It gives logs for all the logs.
No,
All the
it is
components basically.
no. This logs you were seeing, it is only vCore, but it the logs which have been coming, right, it has been enhanced with lot many additional information in on top of what was put in the log file, right? What was getting right, it is coming out on the std out, right, of the container. It has been, that information has been enhanced by multiple additional parameters, okay. So if you probably expand one of these, Divya, you probably will be able to show that. Expand on one of them, okay, any one of them. So a lot of these are kind of some additional information which has been added by Fluentd. All this Kubernetes related namespace ID and all has been added by Fluentd. What is coming from the actual log statement is the 7 to 8 fields you can see at the bottom, right?
Yeah, this level message, and then op ID, op name, RPC,
Yeah. So
this task ID. These are all coming from actual our logs.
Is there a
Did you
way
get it?
so when you list the log table that you only see a certain field or a certain set of fields?
Yes.
yes, yes, I think that's what I think they will probably show. Yeah. So we will add
Yeah,
such
you can
those
add
fields.
some.
Yeah, Divya, go ahead and add some logs.
And level, then message, So it will, in this way, you can analyze the logs in a much better way by adding fields actually. So it will show you the logs for the components with the caller, with the label, and what are the messages coming for that particular log. So yeah, Girish, continue.
It's okay. I think you can go ahead to the next point. I think we probably need to run fast on this.
Okay. So this is all about the developers want to analyze the logs in this way. But with respect to the operator, they are mostly interested in the how many logs are coming in that particular time duration and how many operations are happening and how the vOLTHA is behaving at the point of a time. So for them, the dashboards are more convenient way to analyze the logs and how the system is behaving. So this is a fresh vOLTHA setups. There are no dashboards available right now. But for this demonstration purpose, I have already created a dashboard. I'm just going to go and import it, predefined one. Once import. So you can see in the saved object, it is showing visualizations with that imported dashboard and the dashboard name and everything. So we'll go to dashboard. You can see the dashboard imported, that is vOLTHA inside. So it has a many visualizations we have added for this demo, and it shows the total number of logs in last 15 minutes and how the vOLTHA logs distribution among the vOLTHA components. As you can see, there are multiple logs are coming from the RW core and few logs from a OF agent, OpenVOLT adapter, OpenVOLT adapter as well. And there are many list and get liveliness checks are happening on the etcd. Number of logs count initially was very high, debug logs. Now it is little consistent and it is going down. And the RPC operations which are happening between RW core to OpenVOLT adapter and OpenVOLT adapter to RW core, OpenVOLT adapter to OpenVNU, and this basically gives.
I think what is not coming out clearly is Divya, I think we have selected only 15 minutes. Selected 1 hour because I think the actual enabled device happened around 1 hour or 30 minutes back. So if you select that, you will probably be able to see that it is able to capture for that 1 hour or what all happened.
Okay.
Then refresh it. Now and then things would be, I think, much more clear if you go down.
You can see.
So when enabled device happened, and then you can see the number of etc operations skyrocketed. Right, the logs skyrocketed, and after that it's kind of constant. And if you go down at the end, you can see from the logs we're able to kind of capture the kind of operations across Kafka interface which are happening between adapters and RW core. And this all has been extracted out of the logs. So you can probably create good amount of visual dashboards by extracting information from the logs. I think that's what I think we found to building out.
Okay.
So that's pretty good. In terms of I'm looking at the Kafka or RPC operations. Do you have to do like any plugins or any custom code to in order to feed it into this dashboard in order to know like what are the Kafka operations?
No. I am actually just looking at a message name, and then we are from that message type, right? We are extracting some field out of it, and it automatically creating graph out of it. So we have to kind of create the right visualization, but I'm not doing any. Maybe I'm not hard coding these operations in there. It is automatically, if you have additional operation added into the code today, it will automatically appear in here.
So we're basically parsing the log file and counting how many times the RPC operation pops up.
Yeah.
Yeah, but somewhere you need to know like this RPC means something over Kafka instead of something over gRPC, for example, right?
Yes, but if you see the logs, right, it has been in there's one log which is coming from Kafka intercontainer proxy, right, which says invoking RPC, right, and then there's a
Okay, so
RPC
you're
feed
using
inside
those
it, right?
ones.
Yeah, those aspects we are.
Okay.
So I have another question that maybe was more related to the views we were looking at before, but is there any way through the context or the span to correlate log across containers?
Yes, we will talk about that, I think, in the next
okay.
part of it. Yeah.
Okay, can we move to further topic? If there is no questions. Okay. So next topic would be go back to the discover, and so many times we want to export some logs for specific duration or for some specific component. In that case, there is one feature called reporting. So we'll just see how we can generate a report out of it. So we'll just generate report for RW core logs. So, okay, I'll just take it for the last 15 minutes because reporting feature works with the time. Like if you try to generate a report of a larger file, it will take more time. So I just want to show it with a quick thing. So we'll generate a report of RW core. So you have to search it and you have to save this search. So RW core logs. And then go to share, click on a CSV report, say generate report. So then you can come to stack management. Yeah, it's already created a report. I'll just show you. If you go to the reporting, so it will show you the status of the report, and you can download this report from here. So this is basically the Excel file which you can share with any outsider or any vendor or anybody else, or you can use it for your analysis also. Yeah. So that's all from my side, and Girish will continue with the log correlation.
Okay. So you can stop sharing. I will start sharing.
Yeah.
Divya, you stopped sharing, or you can still see?
I stopped now. No, you are able to see my screen.
No, I think that's fine. I think there's some issue with mine.
Okay.
So I'll start sharing my screen now. let me know. I think once you're able to see this.
Yeah, we can see.
All right.
Yeah.
Okay, so the next part is the log correlation and tracing. So basically, when we started off log tracing and tracing, I think the problem statement we had in I think mind was this 904 GIA, which talks about that we should be able to correlate all the log messages and that pertain to a single user request in sequential order, right? So so we wanted to correlate, right, the logs which are coming from a particular request execution, right? And in addition to this requirement, right, a more detailed I think view of this requirement was that this requirement was because of the problem statement, that because of there was no execution context in the log statement, right? It sometimes becomes cumbersome to perform troubleshooting. Also, when there are concurrent request execution, it becomes difficult, right, to do the analysis. And also, and that is within the component, and let's say I go across the component, right, a request coming from OF agent into RW core, right, even it is very difficult to kind of correlate those, right? So that's a kind of a breakdown of this particular high level problem statement. Another thing which actually came out was that we are not able to do still the execution time analysis, right, how much which operation is taking, right? So what we found out, I think the answer to this was something, I think thanks to Matthew and Hung, who did actually a open tracing based I think a POC early on, right, probably in month of May. We actually took up that as a base, and I think we found out that it is possible to handle both these kind of problems using this open tracing approach. Okay, so we actually took up that POC and took it further and implemented a harmonized solution covering both the requirements, a execution time analysis requirement and a log correlation requirement. Okay. So before I get into open tracing, just to give you an overview, what is open tracing? I think most of them you may know, but just want to probably just to refresh it. It is a kind of standards which allows us to the tracing of a distributed transaction spanning upon across multiple components, right? Usually in a microservices architecture. Very useful for monitoring and the measuring the performance, right? And it provides a set of new vendor neutral API and SDKs, multiple implementation which are available. Two of them prominent ones are Zipkin and Jagger, and we use Jagger for vOLTHA. As we're talking about Jagger, just to give you a view how Jagger basically what kind of view Jagger has. So a Jagger open tracing platform composes of two parts. One is the client part, which attaches itself to the application running as part of a microservices component, right, in a host or container, and then it sends the spans related to the operations application is performing over UDP to Jagger agent, which collects them and further forwards it to a collector. So for each agent application, sometimes there is an agent associated with it on the same node, and then there's a centralized Jagger platform which is collecting the logs, and then having a DB for storing the logs for persistence, and then having a UI and query module for querying that over the UI. Okay. But for our requirement, what we didn't went for this like full-fledged Jagger platform right? But we went with the Jagger all-in-one, which is basically a single container containing all these agent, collector, UI, query, everything in a single Docker container. And it is not using persistence; it is just using in-memory DB for storing the traces. Okay, but I think works well with vOLTHA. But the whole idea is if your organization have a Jagger platform, they can very well use that and direct the spans to that. Okay. Going next, I will just run fast because I think we're running short of time. But stop me, I think, if you have any questions in between. So what we did was we came up with a solution approach at two component level. So within a component, this is the flow you guys all know, that is a API exposed by vOLTHA. The request comes, we hit manager sends a request to agent. So there are internal method calls which keep on happening, and each of the method usually calls the logger, right? So what we did was for supporting this log correlation and tracing. So tracing goes by basically creating a span. So what we did was, yes, a span was created at the API level. So whenever a request is hitting vOLTHA API, a span was created. It was injected into the context. and a span as a ID and a user defined name. This span was propagated across the methods, and also from each method it was propagated to the logger. So you would have seen that each of the method in vOLTHA now has a context as a first argument. Each of the logger calls has a context as first argument. That's why it was done. Okay. Then in the logger, we are extracting the span from the past context object and injecting the extracted fields into each log statement. So you are seeing new log fields in the log statement. We'll see in the demo also. And then when the span gets finished, that's when the operation is completed. What we do is we are also logging it, and that span is getting reported out to the Jagger server, okay, over the UDP, the standard model of sending the span. So when the span gets finished, it is reported out to Jagger. What I was also doing is whenever a call is happening from a component of vOLTHA to external API or any other vOLTHA component, at that point of time also we are getting spans. Okay, for example, if we are RWCO is calling adapter, we are getting a span. If it is calling etcd, we are getting a span additionally. So it is this child span. Okay, so that is happening within a component. Across the component also we are propagating the span. So that is depicted in this diagram. So this is a call flow. I'm just showing a open flow request coming from ONOS. Usually it can be, let's say, open flow add flow request. It is going to hit open OF agent. OF agent is pushing it to RWCO. RWCO is invoking adapter, and then it is going to device, right? What we are doing is gRPC and Kafka interfaces, we have enabled them to propagate span. Okay. So open flow request comes, a span is created, it is pushed into context, and then context is further pushed down to call hierarchy, and span is also carried in the context. Also, what is happening is as soon as we are entering a component or exiting out of that component, is child span is getting created at each level, which means each of the child except the first one is a child. Okay, and that can be traced back to the root span, okay, which is also known as trace. Okay, so the open flow request which came, it created a trace which is also, so the root span is called trace, which has no parent, and it is the lifetime of it is until anything is happening in for that particular root span, right? And each of them is a child span. So this root span created child span 1, child span 1 internally created child span 2, so child span 2 had child span 1 as the parent, and so on. Okay, but each one can be traced back to the root span, so that is called trace. Okay, so this concept which was there in the open tracing has been further used for adding new fields into the logs. Okay, so what we have done is trace and span has kind of translated into what is known as operation in terms of logs and tasks. So operation is the highest level trigger which came from external party. Okay, it can be ONO, so it can be vOLTCTL, right? And it invoked any operation in the vOLTHA component that we are naming as operation. It is same as trace. It is using the same ID as trace, and that log which is corresponding to that operation, right? It will have a op ID as a field and a op name as a field bit. Okay, indicating the name of the operation. Same way as we'll propagate further down into internal component, each child span would create a task. So each child span corresponding to a task, so you will additionally get task ID and task name in the logs. Now, okay, so and also you can further enrich the span. So anything which you have enriched, right, that also attribute would appear in the logs. So for example, you can enrich the span when it invoked RWCO with a device ID, right, which happens in some of the API calls, and then that would also appear in the logs as a device ID field. Any questions till now? Okay, I think we'll look at demo. I think things should be more clear. Then this is an information flow. I'll just quickly go through it. So this is a view of vOLTHA, which is pushing log events and events into log analysis stack, EFK stack, right? There's a fluent D agent which it's called TD agent, right, running on white box. On the other side, there's now a open tracing stack to which the spans are propagated. Okay, it's a Jagger all-in-one, everything inside a single container. So this is a new kind of vOLTHA view which we have just deployed just now. So for tracing also there is a extension which has happened in the vOLTHA. So there are two additional environment variable which have been introduced. One is called width tracing, which default is no. A value of yes would deploy Jagger tracing stack and enables span generation for vOLTHA components, and then tracing underscore GUI underscore port, which is therefore forwarding the port, the Jagger UI to a specific port. By default, it is 16686. Okay. So now we can probably move to the demonstration. Okay. So what's first, I will probably look at the log correlation part of it. Okay. So this is I actually have been running okay, I just probably stop it. I've been running a follows call to collect the logs from vOLTHA, okay, all component of vOLTHA together when I think I got up this setup in the background. So here you can see all the spans which are getting generated, okay. So you may have seen lot of log statements are coming. All the log statement you would start seeing these aspects now, right? You will see op name, you will see a task ID, task name, and op ID, right? This op ID, if I see, right, this is a Steam packet out, right? Op name. I can get all the log statement corresponding to this operation by just searching for this in the logs, okay? So if I just do a cat of log 1 and grab for this, I should be able to see everything related to this stream out request. Okay, now there are too many things because this stream out is going on, right? So it is collecting it and sending it out. So stream packet out is an ongoing operation, right? So you can see a lot many logs which are getting generated. So that way you can correlate all the logs related to which are related to the stream out. In the same way, you can do correlation of all the logs which are getting generated to enable device, because enable device is an operation which just starts off everything, okay, keeps on going. So we'll look at that aspect as well, okay. The same way, but if you look at this, right, you will see op name is always stream out, op ID is always the same, but your tasks keep on changing because this high level operation of stream out is invoking multiple internal tasks, right, and internal operations across RW core and OpenVOLTHA. So you will see, I think, multiple task name will keep on changing, right? So there's a different task name, okay, which is repeating and all. So I think we will probably look at it in the Jagger UI also. In the interest of time, I'll probably stop on this. And this op ID also propagates across the components, okay. So let me, I think, switch on to the Jagger UI, okay, in the interest of time. All right. So this is a Jagger UI which we're talking about. I have kind of done a port forwarding to get this. All right. Not too sure why it is saying it is not accessible. I hope there is nothing wrong which has happened. Okay, just a minute. I need to maybe create an, I think one of my sessions actually died away, which I was using for tunneling. Let me do that. All right, I think hopefully it should be okay now. All right, okay. So so this is, this is a Jagger UI where you can analyze the traces, right, generated by each component. So you can see 3 components: OpenVOLTHA, which has generated almost this 39 different type of operations it has done, right? So it is, some of them are operations, some of them are tasks. We'll see, I think, how to look it out. So it is reporting all the Kafka related operations, right, whatever it has invoked, so you can find out which operation invoked at what time and all, right. Then let me go to the read-write core, which are showing 36 operations. So let me look at, for example, create device. When did it happen? It happened around 40 minutes earlier. What did happen, right? So when a create device happened, these are two internal etcd operations were processed internally, right? Same way, I can see OF agent. OF agent, I will probably show you a operation which keeps on happening. So OF agent, you know, right? There's a refresh device list. This keeps on happening every 1 minute. So it's, you can see a few seconds it happened 2 minutes back, and then all right. It invokes, it gets started from OpenFlow agent. It goes to open to RWCO, and on RWCO it performs a TSD operation. Now let me, I think, show you the, the beauty of this part. Okay, that would probably be clear if you look at the more of the complex operations. For example, let me look at enable device. So once we have clicked, sorry, I think I clicked on something wrong. So I search for enable device. Okay, so here you see number of spans enable devices generated. Okay, it is still going on because enable device, when it happens, it starts from redirect core, it goes into OpenVoLTH, and in OpenVoLTH that threads keeps on processing things. It doesn't stop. It's a go routine, keeps on going on. So I just I just go into this. I can see as of now there are 1700 spans, right? I click it again, you will see it will increase. 17, 15, 7 more has happened because it is a ongoing operation. So when enable device happened, it started from RW core, it did a lot of etc operation, then it got into adopt device, right? Then it did a lot of so it OpenVoLTH invoked multiple operation to RW core, and then it went down, and somewhere you can see it did a list device port. Okay, when the interface came up, operation indication came, then it did a port kit, call the port created towards RW core. Then ONU indication would have come, right? ONU indication came, it found out that the ONU is there, that it created a child device, right? And once that had happened, this OMCI indication started coming, and for each OMCI indication, it is invoking a call onto OpenONU adapter, right? So you can see it is actually an ongoing thing. And it is listing each, okay. So it is just too many, I think, spans to handle. So I probably look at a smaller, simpler one, which is still complex. For example, if you look at OpenFlow agent, there's a one span I want to probably show you is OpenFlow flow add. Okay, this is actually called once the flows are ready to be added, right? Once the once the ONO sends out, right, a request to add the flows, right? So this came from OF agent. It invoked the RW core, right? Update logical device table. Then it can do OpenVoLTH. In OpenVoLTH, you can see it invoking the creative scheduler. And here you can basically, I think this view gives you a very good idea of how much time each operation is taking, but all operations are happening. Unfortunately, we don't have the open ONU adapter traces. If we get that, I think we'll also see a continuity. Once this actually sending a open ONU Kafka RPC request, you will also start getting span from there to understand what is happening in there. Okay. Another view, alternate view.
Quick question, Girish.
Yeah.
If I look in the spans, can I see the task ID and the operation ID so that I can eventually go in the log?
Yes. So okay. So if you look at this, right, this is your span op ID.
Oh, okay.
So okay. So if I go back in the log one we had, right, so I can just hold on this one. So I can do a look at log one, grab for this. you'll get all the logs which happened corresponding to this particular processing across the components.
Right. And I guess I can do the same in Slack, just setting up a
Yes.
filter.
Yeah. So we're using the same op ID, same trace ID to populate top ID. So it provides a kind of a connection between traces and logs.
Okay, thanks.
Yeah. So yeah, an alternate view. I think we should. I just want to probably spend a minute on this. Is this? So that was a time view. This is a view of what all services are involved in this trace, right? So let me, I think, zoom into this. So it is showing that from OpenFlow agent, which API OpenFlow had called this service, this internally called RW core, and RW core. I think this level is okay. Hope you're able to see, right? So the RW core update logical flow type table is calling internal operation within RW core, which is then taking it to adapter OpenVoLTHA, where multiple such operations are getting called. Okay, you can also see how many times which operation got called. So it adapter OpenVoLTHA etcd got called 16 times. What is a percentage of overall time it took? Okay, what total time it took? Okay, those I think information you can see. And these are kind of service view. So because you can see each service in a different color, right? Then you can have a timeline view which shows which operations are taking a lot of time. Okay, so once you see in red are taking more time, then there's the next ones, right, which are probably taking lesser than that, and then they are kind of white, which are not taking probably a lot of time. And then there's a self time, which is talking about that particular operation in it itself is taking how much time. Okay, so here I think I've not gone to self time yet. I'm only on a time. Time is showing the collective time. So this is taking so much time. So it is being in red because probably sometimes its childs are in red. Okay, so if I go to self time, I will see a view that these operations are taking more time by themselves. Okay, so okay, so I think that was the part of this. I think I've already talked about this now, right? So the trace ID is also in the logs as op ID. Okay, if you want to look at a specific task, you can also go back to here. Look at a different other view. Okay, sorry, I think so. Here, if you expand on this span ID is your task ID. So I can copy this. Right, it would still have the same op ID, but task ID would be that. Okay, so it will have probably not that many logs. Okay, it is copied correctly or not? It is copied correctly. Yeah. So this is, I think, the task ID you can see, right? So this is only showing the logs which are related to this particular vOLTHA logical device flow table operation. Okay.
Yeah.
Yeah. Sorry. You're saying something.
Just a quick question. Like it's this is pretty good. We don't have ONU adapter at this time because it's in Python, right? That's why it's not integrated.
Right.
Since you're using context for this approach, we're using span. Does it mean that we'll only get data if we have process written in Go only?
We will get only. I didn't get your question. Sorry.
If we have for example, the same thing, can we have the same thing from the ONU adapter, like which is written in Python? Like,
yes.
Is there a precondition that the code has to be in Go in order to get span data added to it?
No. It can be done in Python also. It's just that it would need additional effort. but we were thinking probably by 2.5. I think it's not, I think, happening, but we thought probably maybe by 2.5 we will have this OpenONU adapter available in Go also. So we thought probably, I think, we take it up at the end. But yeah, I think if we want to do, we can do. I think it's not. We have the, I think, this instrumentation library for Jaguar available for Python also. So we can do it in for OpenONU adapter also. It will take some effort.
Okay. Okay. Thanks.
Yeah. And before just we end, I think just one other aspect I want to probably talk about is that this is, I think, dynamic. So what I can do is, let me keep on following this, drilling the logs, and what you can do is you can enable and disable the logging. Okay. So what we have added these two commands. These are still a work in progress. There are, I think, patches in there, but I think it probably get merged in a couple of days. By the end of this week, you should have these commands. But what you can do is you can enable, disable correlation and tracing. So you can do enable. So because if you're saying, let's say you're getting a lot of logs, right? These are currently enabled on all the three components. If I do a disable, I can disable on a particular component. For example, I can say read code, disable, enable, disable it. So from the read code, whatever logs are coming, it will not have now those op ID and task ID addition details. Okay. If I don't give it any command, any component name, it will disable it for all of them. Okay. Same way you can enable and disable the tracing independently. So if you disable the tracing, no traces will be sent out to Jaguar. So it is currently by default enabled. I can do it disable. So if you see, right, in the Jaguar UI, currently you may be seeing logs coming from, right, let's say, I think I just want to see some of the logs which usually comes, right? For example, we have this list logical devices, right? This is a operation which performed every, I think, minute, right, by the by the OF agent. If I just disable it, I will not get any further traces on this Jaguar. Anyway, it will take 1 minute for you to, I think, know, but that's, I think, a feature I just want to probably indicate that we have, I think, way to disable tracing and correlation, both of them. Reason being, I think you may want to have a lesser amount of log, right, fields. Sometimes you want to not have tracing enabled because that adds on some additional CPU cycles that could be saved because of this. If you enable disabling both of them, we in fact actually there's a tracer client instance which is created for Jaguar. We actually totally destroy it if both are disabled, so that you don't save. I think you don't I think spend any CPU cycles on that part. Okay. Coming back to presentation, just one last slide I want to talk about. So this is something which is just pending. So this is something which we have completed, and I think by the end of this week we will a few patches which are pending, specifically related to enable disable, and they should also be in. As I think as you also indicated, I think span generation can be extended to these two components, OpenONU adapter and OpenONU agent. Okay. We probably were waiting for Golang based adapter, because if you go for Golang based adapter, it is just calling two methods in the VOLTHA libgo to enable it, nothing more. Okay, just in a config we have to add 3 config parameters and then creating calling 2 methods into VOLTHA libgo, and that would enable it for them also. Then
what is OpenONU agent?
Okay, sorry, I am sorry. So it is OpenVOLT agent, I think. OpenVOLT agent, which is running on the right VOLT.
Yeah. Okay. Thanks.
Sorry. Yeah. And then spans can be enriched to get more information if you want. We are not pushing in a lot of information to span, and so now only device ID is pushed for device related operation. but we are not adding any further data. But if you add them, that would also appear in the Jagger UI. If you want to use UI for analysis, for example, I can go to one of this. List logical devices, I would start getting them as tags here. Okay, for example, refresh device list, you should be able to see a log, right? This way you will start getting additional information about it.
Yeah, I will say not to put too many information with the spans because
Yeah.
they travel on the wire together with the context of every call. So if you put too many things into there, the main traffic.
Right, you're right. That's why I think we didn't do that also. We only added device ID only for some of the device operation like enable, create device and all, but nothing more. vOLTHA we can also add, but this would have limited benefits. We have not added span generation for the initial startup or stop procedure of the components and the housekeeping stuff, because that would probably would not have any value add. So you will not see all the log statement having op ID and task ID, because many of the log statement are related to the housekeeping, right? Internal Go routines running to do some housekeeping or right, checking the liveliness and all that stuff. And then I think this one thing I wanted to do, but I didn't get the time. I want to do the impact analysis of enabling, disabling, and the performance. I want to see how the performance of gets impacted because of this. But yeah, was this one thing you probably explore if you want to probably see the impact. I think that is all. I think we're just on time, probably a couple of minutes, right, over the time.
So for the scaler, I think I'll probably give it a shot to add it to our test pipeline once all the patches are in. And so that should give us an easy way to measure the impact, if any, on the performances.
Right.
A quick question: Is there any write-up on the, if I want to try it out in my environment? Is there any write-up on it?
I think we added in the README that how to enable tracing. But I think on the design, I think most updated version is this slides. I can share that. But there's nothing else you need, okay, in terms of like, if you enable the bit tracing and if you probably follow the steps, right, you have to open that Jagger UI. I think you should be able to access it.
Girish,
Girish,
the README you mentioned is the kind vOLTHA README, or is
kind vOLTHA?
Okay.
Yeah, kind vOLTHA README.
Maybe one thing that I would like to see is that given that kind vOLTHA only touches the vOLTHA components and not the OpenOLT agent, for example, all the stuff that was related to the OpenOLT agent, I would like it to get documented, for example, in the vOLTHA docs with all the steps that are needed to include what you have shown today in a running EdgeCore OLT.
Okay. That part, I think, yes, I think we have to add that. We have not added that. I think we discussed in the last meeting, but yeah, we will add that. I think we'll probably do that. Yeah, sure.
Perfect. Sounds good.
Okay.
But I have added in the README of a OpenOLT agent that how to install and all those steps are there.
Is it okay?
Yeah.
Can you just check?
Yeah, it's already there. I'll update the design document and I'll share with you guys.
So India probably have a look. I think TD agent related details may be there. I think more detailed steps are there.
Yeah, it's there already.
Okay, thanks. That's great to hear. Does anybody have any more questions for Divya, Girish?
I had a question about the OpenOLT agents. Have you done any initial exploration on what it would take to integrate this with the OpenOLT agent? It's in C++.
You're talking about this Jagger, right? Opentracing.
Yeah.
So it provides C++ libraries.
Okay.
C++ client libraries. So we have to probably use it. And over the gRPC interface, we already sending the data, right, in the additional headers. So, but that is not getting used, right, on the other part side.
Yeah.
So once we have that client over there, we can use it, yeah, and push that data into the Jaeger server.
Okay. Thanks, Girish. Yeah, it was this was great.
Yeah, I think the best part I think found out was it is actually also allowed me to understand the whole flow. Okay, I think because we have connected all the dots, right, using context. Anyway, I think
yeah, I think this is super useful when debugging some failure to have that visual guide through what is actually happening in that code. I think it will prove to be very, very helpful in improving performances and debugging failures.
yeah.
Just to confirm, like in the example that you gave, you showed that the route span was created with a request coming in from the northbound. Yes, if there are requests coming from the southbound, that will also be applicable, right? Like for example, if a port is changed state, and that's where it started.
Yes.
And then that would be, it will create a route span at that southbound. Correct?
Yes, that was actually happening. If you see, it was happening. So, but actually, all the southbound which are coming, right? They are, for example, southbound what are coming are indications, right? So that you can see in the indications, right? In the enabled device flow, you could see a lot of indications which came in, right? They were actually part of the same execution flow. So that is why I think, okay, enabled device, it was beyond 1 hour now, is it? Okay.
Yeah, that's okay. I just wanted to confirm that it's.
Yeah, it happens. Yeah. So all the ones which are coming from actual the OLT that are also coming in. So you can see all the OMC indications are also getting captured here.
Okay, great.
This is interface indication. Right? But that is always a task because it all happened as part of the execution flow which started with an enabled device. It's the same Go routine which is kind of processing it.
Yeah, but if there's something new start from the OLT, for example, the device change state, then that would be the route span, right?
Yes, that would be. I think I have not tried that, but that definitely, yeah, that should.
Okay, thanks.
Okay.
Thanks, Girish. Given the fact that we are 10 minutes over, I think we can call it a day for this meeting, and the investigation of gRPC secrets and other discussions will slip to next week. So I will publish the recording as usual. Thanks a lot for providing the demo, Girish, and thanks for the great work, both of Girish and Divya and the whole team. I look forward to using this, as Matteo was saying. I think it's a great feature. Before we close, any final remarks, anything that I missed that somebody wants to share?
It's pretty good.
Yeah, I think this is amazing. Thanks so much for putting this together.
Yeah, thank you. Yeah, thank you, community. I think thanks to whole community. I think even David and Scott helped us a lot. On reviewing things, and then later Kent also joined in, and we had to put in a lot of patches. And thanks for all who reviewed it.
Thanks, everybody. Well, have a nice day and take care. Bye-bye. Cheers.
Thank you.
Guys, have a good day.
Thank you. Bye.